Alternating current occurs when the power source provides an alternating voltage following the equation maximum output voltage multiplied by the sine of omega, or angular frequency, times time. This type of current can be produced in either of two ways: by spinning a coil between two magnets, or by spinning a magnet between a coil. This graph shows alternating current with voltage on the y-axis and time on the x-axis. Here we see a sinusoidal waveform with one cycle, or period, outlined. The amplitude of the waveform is shown as well. Different waveforms of alternating current can be produced, such as the complex wave, triangular wave, and square wave. AC power allows us to effectively transmit electricity over great distances using high voltage with little power loss. The top equation dictates power loss due to resistive heating. By decreasing the current, we can greatly reduce the power lost. But if we'd like to keep the same amount of power transmitted, as we see in the second equation, we can transmit the same amount of power if we decrease the current and increase the voltage. The varying current provides us with the ability to use transformers. Transformers allow us to step up or step down a supplied voltage through the use of varying coils. As seen here in the diagram, our primary coil has many windings, whereas our secondary coil has only a few. This will bring down the supplied voltage to a more functional and safe voltage for use in businesses and residences. The reverse of this diagram could be used to bring up the voltage to transmit over high voltage power lines. Visualizing the entire process, after the AC power is produced using a specific type of generator, it becomes stepped up to a higher voltage using a transformer, where it is then transferred across high voltage power lines to be again stepped down to a much safer and more functional voltage to be used in businesses and industry, where lighting and motors can be used with this type of power. Alternating current allows for the transmission of radio waves. The two primary types of antennas for transmitting and receiving signals are the dipole antenna and the loop antenna. Both of these designs can emit electromagnetic waves and receive them as well. Radio waves can be broadcasted in two different formats: AM, or amplitude modulation, or FM, as frequency modulation. As their name implies, AM radio modulates the amplitude of a signal to transmit info, whereas FM radio modulates the frequency of a signal to transmit info. The two bands cover from 500 to 1700 kilohertz for AM and 88 to 108 megahertz for FM. Another interesting phenomenon with alternating current is its application with piezoelectric materials. Piezoelectrics turn mechanical stress into a voltage difference, or vice versa. For my independent study research project, I will be using an ultrasonic piezoelectric transducer to transmit a frequency given by the frequency I set my alternating current to be running at. At the same time, I will be using another piezoelectric microphone to measure the frequency of sound generated within my flask. In this short video, we've covered the fundamentals of AC power and its many functions, from high frequencies being used for transmission of radio waves and signals, and lower frequencies for the transmission of power. Without AC, the world wouldn't be as bright as you know it. Thanks for tuning in.